Okay, so let's talk about how to evaluate logs. So let's say we have log base 2, right, of 32. So if you want to know what this equals, what you want to think is, well, the base is 2, so that means 2 to some power, right, some exponent, 2 to some power, has to give you 32, has to equal 32. Well, we know 2 to the 5th power, to the 5th power equals 32. So we know the answer to this is, right, 5. Okay, let's try another one. Let's say we have log, right, base 3, 81. So this means that I'm trying to think 3 to what power is going to give me 81. So we know 3 to the 4th power is equal to 81. So log base 3 of 81, right, equals 4. Okay, so sometimes when you're evaluating these logs, it's very obvious, right? But sometimes it's not so obvious. So we have some special cases that we want to memorize, all right, to help us evaluate some more difficult logs. Okay, so let's take a look at those. Okay, so let's take a look at the special cases. Okay, so basically, whenever you see these special cases, you have to remember the answer right away. So if you have the log, all right, and the base, right, and the base, and so the base and this value are exactly the same, all right, this is going to equal 1. Okay, the reason why is, if you think about it, if you convert this, if you change this into exponent form, right, 3 to the 1st power is going to equal 3, right? So that's why this equals 1. So you have to remember, anytime a log, so like if you see something like this, whatever the base is, let's say the base can be anything, right? Let's say it can even be a fraction, 1/4. And if this is 1/4, if these are the same, we know this is going to equal 1. Okay, it's going to equal 1. The other special case, now, if this value here is 1, right, then you know that this log is going to equal 0. Because right here, if you convert to exponent form, 3 to the 0 power is going to equal 1. Okay, so anytime this value here is 1, right, then we know that the log is going to equal 0. So let's say you have something like log base 12 of 1. We know this equals 0. Okay, now what if the log and the base, these are the same, and then this has an exponent? Well, the answer will be the exponent, right? So for example, we will have, let's say, something like log base 6 of 6 to the 3rd, right, of to the 3rd power. Well, if these are exactly the same, right, if the base and this value here are the same, then that means that the answer will be whatever the exponent is for this. In this case, it's 3. Okay, so these are special cases that you need to memorize, so that when you're simplifying or evaluating kind of more complicated logs, they will help you, right? And I'll show you in a few examples in a moment. This special case here, now this is actually in exponent form, right? So this is actually in exponent form, and the base of the exponent is 3, and the exponent is actually a log with the same base. Okay, so whenever you recognize this situation here where you have this, the answer will be, all right, whatever this value is right here. Okay, so I'll give you an example. So let's say we have 5, all right, is the base. The exponent is a log where the base is also 5, and let's say this value is, let's say, 17. Well, whenever this right here, the base is, all right, and the exponent is a log with the same base, when these are the same, the answer will be whatever this value is right here. So this is going to equal 17. Okay, so these are special cases that you just kind of have to recognize and remember, and it will help you evaluate more complicated logs. Okay, now it works the same way if they're natural logs. So all of these are the same. It's just a natural log. So now remember, the base of the natural log is always e. So if you see this is e right here, that means this is going to equal 1. Okay, so just remember, all right, natural log e is going to always equal 1. Okay, because remember, the base here is an imaginary e. So when these are the same, it's going to equal 1. Okay. down here, if this value is 1, just like we talked about over here, right, this is going to equal 0. So natural log 1 is going to equal 0. All right. And the same thing here. If the base is e, well, if these are the same, the answer is just going to be the exponent. In this case, it's 7. Okay. And now over here, if you have an exponent form, the exponent, or the base is e, right? And let's say the exponent is a natural log, and to some value, let's say natural log 13, well, this is just going to equal whatever that value is right here, so it's 13. Okay, so you just kind of have to memorize these special cases, and they'll be useful for evaluating kind of more complicated logs sometimes. Okay, so let's do some examples so we see. Okay, so let's take a look at this example here. So first of all, right, you should recognize this is one of the special cases, right? So with this value here, right, we have log base 8 of 1. So when this value here is 1, you have to remember this is just going to equal 0, right? So this right here is actually equal to 0. The reason why is if we have 8, right, to the 0 power, that's going to give us this number here. It's going to give us 1, right? So this is just one of those special cases. Remember I said whenever this value here is 1, we know that the log is going to equal 0. Okay. Over here, we have another special case. So remember, in exponent form, if the base of the exponent and the base of the log, right, which is the exponent, if these are the same, your answer would just be whatever this is over here. So it would be 3 to the 4th power, in this case, 81. Okay, so these are just the special cases that help us kind of simplify more complicated logs. Over here, same thing. We see that this is a 1, so we know this is just going to equal 0. Over here, so we have to manipulate this a little bit. So if you think about this, log base 3, 1 over 81 is 3 to the negative 4th power, right? So, and then we use the special case. Well, if you have log base 3, if this value and this value is exactly the same, we know that the answer is going to be the exponent. So this is going to equal, all right, negative 4, right? So this right here is going to equal negative 4. Okay, so this is how we're using these special cases to help us simplify some more complicated logs. So let's take a look at a few more examples here. So over here, right, so this one is kind of a very basic one. You should be able to figure this out. We know 2 to the 4th power is 16, right? We know that 2 to the 4th power is going to give us 16. So we know this right here is going to just equal 4, right? It's going to just equal 4. Over here, this one's a little bit tricky because you kind of have to convert this since it's a decimal. You have to think of this as, well, this is 2 over 10, which simplifies to 1 over 5, right? Now, if we can get these values to be the same, we can, right, use one of the special cases. So we go log base 5. This is the same thing as 5 to the negative 1. So the special case says when the base of the log and this value is the same, the answer will be the exponent. So the answer is going to be negative 1. Right? Your answer is going to be negative 1. Okay? And let's take a look down here. Okay, let's take a look down here. So we've got, now if this is in a surd form or radical form, you want to change it into exponent form. So we have log base 10. This is going to be 100 to the 1/5 power, right? Now we want these values to be the same, so I'm going to change that 100 into 10 squared. And then we have the 1/5 on the outside. So follow exponent rules, multiply the exponents. So we're going to get log base 10, all right? And then we're going to get 10 to the 2/5 power, right? So following, all right, the special case, if the base of the log and this value are the same, the answer will be the exponent. So the answer is going to be 2/5. Okay? Over here, same thing. I want to convert this surd or radical into exponent form first. So we'd have 1 over 2 to the 1/2 power, right? Now I want to move this to the top. I don't want this to be in the denominator. So I move it to the top. So that's going to make that exponent negative. So we have 2 to the negative 1/2. And once again, we have the special case. If this and this are the same, right, the answer is going to be the exponent, which is -1/2.